Alright guys, let's take a look here. So this first problem, I didn't do a problem exactly like this, because I'm evil, but it's the idea. Why do we graph anything? So that I can see all the answers. So if it wants to be an answer to the question, it's got to work in the equation, right? So if it works in the equation, it must be on the line, because all the answers are on the line. That's the idea. So when I plug, now here you can't go wrong. 2, 2. So 2 minus 3 times 2, is that 4? 2 minus 6 is negative 4. Is that 4? No. So number one, it does not answer that equation. It's not a solution to that. And secondly, it must not be on the line. Because what's on the line is all the stuff that actually answers it. I like it. So no. No, no. So this one, this is A, this is B. So 7 minus 4 times 1, is that 3? Yes. 7 minus 4 is 3. Therefore, that point, 1, 7, must lie on the line of this. Now, in this case, it would be the A-axis and the B-axis, but who really cares? What's special about X and Y? Not a damn thing. It's just that they just picked those, right? I think it was early mathematicians were pirates or something. I don't know. We're the X. All right, bad joke. I don't care. So it could have been A and B, it could have been anything. Alright, we're going to normally deal with X and Y, just to keep it what we're used to seeing. Now number 2, please, dear God. If there's a problem where you have to plot a bunch of points, number 1, put them all on one graph, and number 2, label them, so I know what's supposed to be what. Okay. So I love it when people give me just a bunch of measles on a page, and I'm supposed to grade that. So first thing you do for yourself is to label these. Now one big thing about graphing, I could make the scale different. I could make it 2, 4, 6, 8, 10 if I would have given you something with an x of 10. So you don't have to use a scale of 1. You could use a scale of 2, 3, 4. It doesn't matter. It just has to be consistent. You can't go 1, 3, 5. Why couldn't I do that? Because this would be 1 and then this would be 2 and 2. You got to go by the same amount each time to make it honest. So where's negative 3, comma 2? Yeah, 3 back. Up 2. I like it. So that's point A. 5, negative 2.
Over 5.
5 over?
And up 2. Or down 2.
Down 2. I like it. That's B. 0, 4.
Is on the line and up
Yes,
4.
stay here. Up 4, I like it. So the first number tells you how much to move left and right. The second one tells you how much to move up and down. Now, just to blow your mind a little bit, in real life, hopefully you realize we live in 3D. Thank God. If we lived in 2D, that would be... So we're not going to do this. But there would be a third axis coming straight out. That would be, incredibly enough, it would be the z-axis. X, Y, and Z. So if I wanted to find, like this point here, that could be maybe over there, up there, and then out this much. It would be a point with 3 parts to it. You guys understand? And we're not going to do that. Don't freak out, but just let yourself realize that makes complete sense. Makes almost too much sense. I like it. Well, we won't do it. Don't freak out. So that's C. D, negative 1, negative ISO.
To the left and then down.
That's D. I like it. 3, 3. Can't go wrong.
Yeah.
3, 3. That's E. And then negative 5, 0 is going to be on the what axis?
It's going to be on the X.
X axis. I like it. Because you don't go up and down any. You just go back 5. I like it. By the way, when I create this, I cut things up into 4 parts, right? This is good. So quadrants. Spell, Jeff. Oh, screw it. Quadrants. Conjunctions. Oh, it's right on the edge of that. That's why I won't make an A. Yeah, Jeff, that's why. 1, 2, 3. They decided to go counterclockwise just to screw people over. This is quadrant 1, quadrant 2, quadrant 3, quadrant 4, in case that comes up. If I was in 3D, it would make octants. Well, let's not worry about it, sorry. because then it'd be 8 parts. Now here, hopefully this was pretty simple, I'm hoping. Is part A, is that a function, what they've got there? Yes. Why?
Because each D has only one outcome.
Every element of the domain, every x value, goes to only one y value. I like it. Even though they share it, who cares? They can share. What about part B?
No.
No, why not?
Because they share the 5.
Because 5
Has more than one outcome.
goes to 3 and 2. That's no good. So that's why right there. No, because of this. I like it. What about part C? No. Why not? 9 goes to more than one thing. It goes to 1 and it goes to -5. So it'd be just like this if I wrote it like this way. No. What about D? It's fine. Even though this is the same, who cares? 2 only goes to one thing, 3 only goes to one thing, 9 only goes to one thing. That's what I'm looking for. Every x can only go to one y. And what about visually, part E? No, because I just have to draw one vertical line. That x goes to more than one y. No. What about F? Yes, because every vertical line I can imagine goes through only once. It passes the VLT. It passes the Vult. The venison, lettuce, tomato. Anybody out there? I don't know about venison. My grandpa made venison chili and almost killed him. It makes it. Spoon was melting. Back in the day. Let's see. So, okay, how are we doing so far? Is that the first part up there? I mean, you should come into this class knowing the plot points. That shouldn't be a big deal. This might be a little bit new, but you're just plugging in and seeing if it's true or not. And the idea of a function, hopefully the idea of a function makes sense. There's multiple ways I can ask you the same question. Number 4 is where we get into just pure plug and chug stuff. So which function am I using here? The first one, huh? So then I just put 2 times -1 minus 1. -2 minus 1. -3. So again, it goes to the point -1, -3. Kick ass. Only one point, not good enough to graph it, but it does go through that point. H of 3. 3 squared. Minus 1. 9 minus 1. 8. Yeah, 3 comma 8. I love it. G of 1.
1 minus 1.
1 minus 1 over.
1.
It almost doesn't matter what's on the bottom.
0 over 6.
Yeah, 0 over 6, so it's 0. So it goes to the point 1, 0. Kick ass. And then I had to throw you this one. H of M.
M squared minus 1.
Yeah. Whatever. The process doesn't care what's in there. Whatever's in there, you put it in. So we were cool with H of X. We should be equally cool with H of M. H of X is X squared minus 1. H of M is M squared minus 1.
So you would write it,
Can you add 1 to the other side? Are you solving for M?
I can't solve for M because I know H of M equals M squared minus 1.
but when you write it, like, do you write
This is it.
M and then
Oh, what point does it go through? M squared minus 1. That's the point that it goes through.
okay, that's what I was asking.
Now, why does it look freaky? Because I actually didn't tell you a number. I just gave you a different variable. So on one level, it's like, why would we do that? But believe it or not, I could have put like an M minus 7 in there, and that would actually shift things over in terms of M. It's a little bit beyond what we care about, but you should be able to handle me just throwing letters in there, because that's what starts off in there is a letter. So who cares? You just throw the different letter in there. Ooh. But your brain kind of feels like it should go further, because your brain, it can't do anything with that. Stop. All right, number 5 might have been a little bit freaky. But number 5 is sort of like putting some ideas together. I didn't tell you what f of x was. Don't go back and use the one up there. This is number 5. Totally different problem. I didn't tell you what it was. I don't need to. Because what do we normally do? If I wanted to make a graph, I have to make an XY table, put a bunch of shit in, get a bunch of shit out. I get a bunch of points, and then I plot the points and I connect them. Somebody already did all that work. I've got all the answers already. So when they plugged a -1 into the function, can you tell me what they must have gotten out? When x is -1, y is negative. There it is.
I didn't know how to answer. I just put negative.
Oh, that's how you answer.
Oh.
Good. And then what about f of 0? When x is 0, y is -2. Did you guys see that?
Look, so it's on the point, and that's your answer.
That's it. Yeah. So why did they put a point here? They must have put a point here because when they plugged a 0 in, they got a -2 out. So then when I say, well, what do you get when you plug a 0 in? You get a -2. I can see it just staring me in the face on the graph.
So the answer would just be negative. So.
Yes. The answer is just -2.
What if you put 0 negative, comma, and say negative 2?
That's not quite right because the answer shouldn't be a point itself.
Okay.
The answer should be the y piece, the output.
Because that's the
When
X.
x is 0, f of 0 is -2. That's the
Like,
output.
what is Y?
Exactly. So this is really saying, what's y when x is -1? What's y when x is 0? That's what that really is asking. And now I gave you this, I just threw this in there. The book doesn't really make a big deal about domain or range, but I just want to see who could figure this out. Remember, domain is a collection of all of the
X.
x's. So what's the smallest x that it looks like it uses?
0.
No?
Negative.
Doesn't it use -1? Didn't we just use -1?
Negative 3.
Doesn't it also use negative? Doesn't it use -3? Yeah. -3 has an output, doesn't it? So the smallest x I see that's being used is -3. And the biggest is
1. Wait.
2.
6.
Because 2 has the output. No, 6 is a what value? 6 is a
Y.
y value. This domain is all about what x's were used.
Oh.
So domain is really what inputs have outputs. -3 all the way up to 2. So you can say like this, from -3 to 2. What about the range? What outputs happen? What's the lowest output that I can get? -3.
Negative 3, yeah.
And what's the highest output I can get? 6.
Okay.
So that one's a little bit freaky, but I wanted to see if anybody could get that.
I don't know.
So any questions on that handout there? How do you feel about that?
So, with number C, do you just write it like the number to the other number?
Yep, that's fine. Normally we would write it in interval notation, but this book doesn't have interval notation, is that right? I think not. Does it? No.
I thought you were supposed to do the chart.
No, the interval notation. You like bracket, -1 or something.
Write it like that. -3. 2.
Yep.
How did you do this?
What's the lowest x that's used? -3.
Okay.
And then I use every other x up to 2.
Oh,
Beyond 2, there's no output.
you have
Beyond,
to include the lowest and the highest.
yeah, well, everything that has an output. Every x that has an output. So every x from -3 to 2 has an output.
Right. So if there was, say,
If there was a hole somewhere.
5,
Oh, okay,
you know
sure.
what I'm saying? You would always write the lowest one and the highest one.
Yes. We'll keep it there because we're not going to have any free. There are chances to have a hole somewhere, and then I have to exclude that because there's no output there. Yep. You could have holes in functions. There could be a point where the function can't handle it. Yeah, you could have a missing observation, which means there'd be a hole.
Bye, Jeff.
See? Or there
So
could be,
if there is a possibility it could be like 3 to 2 and then 5 to 6.
of course. Well, like -3 to 2, 5 to 7. Smallest to biggest, yeah, like you said. Cool.